Imagine this, 7 giant comets, all blazing toward the inner solar system, at the same time. Astronomers are calling it a once-in-a-century cosmic traffic jam. Solar physicists are on edge, satellites are on standby, and for a few weeks in 2025. Even casual skywatchers might witness glowing tails streaking across the dawn sky with the naked eye. What's going on with our solar system? And could this rare comet swarm trigger the kind of solar chaos we've only seen in simulations? Let's break down the rarest comet calendar of our lifetime. In the world of astronomy, comets are like time capsules, icy messengers carrying dust and gas from the dawn of the solar system. But in 2025, something extraordinary happens. 7 major comets, all visible within just a 6-month window. Most years, scientists are lucky to study 1 or 2 bright comets up close. 7 in one season? That's the kind of record that hasn't appeared in modern observation logs, not even once in the digital era. The last time humanity saw this level of comet activity, astronomers were still using glass photographic plates. Today, with high-tech telescopes and sky surveys like Pan-STARRS, Atlas, and SWAN, we're entering an observational golden age, and this swarm might just push our understanding of the Sun and its visitors to new limits. From July through December 2025, 7 icy travelers will sweep through the inner solar system, each with its own unique path, timing, and personality. The lineup begins with C/2022 N2 Pan-STARRS, which sets the outer boundary of this event. Its closest approach to the Sun, called perihelion, arrives on July 31st, though it stays far beyond Mars, visible only through deep space telescopes. Think of it as the quiet overture before the show begins. Then comes C/2025 R2 SWAN, a speedster that races toward the Sun and swings by Earth at just 0.25 astronomical units, roughly 37 million kilometers. That's close enough for backyard observers to catch it glowing faintly in the pre-dawn sky of the northern hemisphere around October 21st. Next up is 414P/Stereo, diving below the ecliptic plane on September 27th, hidden in the Sun's glare, best seen by space observatories, not by human eyes. Its trajectory offers scientists a rare look at comets from a solar spacecraft's perspective. Then there's C/2025 K1 Atlas, and this one's wild. It swings closer to the Sun than Mercury ever does, only 0.33 astronomical units. Such a tight pass means its icy nucleus will erupt violently as it heats, releasing plumes of gas and dust that could reshape its tail within hours. Meanwhile, 3I/Atlas, the interstellar outsider, streaks in from beyond our solar system. It's not bound to the Sun's gravity, just passing through. That alone makes it one of the rarest visitors we'll ever see. Its path will take it behind the Sun from Earth's point of view in late October, before re-emerging as it exits our cosmic neighborhood forever. Then comes C/2025 A6 Lemon, perhaps the most photogenic of the bunch. It peaks on November 8th, glowing possibly bright enough to be seen without any telescope, maybe magnitude 4 or even 3.5 for northern observers. Finally, 240P/NEAT closes the year on December 19th, faint but symbolically marking the end of this historic season. Together, these 7 objects create a celestial choreography unlike anything seen in the last 100 years. Comets may look gentle and beautiful, but they're anything but calm. When one approaches the Sun, solar radiation heats its surface, turning frozen ices into jets of gas and dust. That outflow forms 2 distinct tails, a pale dust tail and a bright blue ion tail. The dust tail curves gently away, following the comet's orbit. But the ion tail, made of charged particles, is a direct link to the solar wind, the Sun's invisible river of plasma flowing through space. Every now and then, something dramatic happens. The comet's ion tail simply snaps off. Astronomers call this a tail disconnection event, a breathtaking reminder of how violent the Sun's magnetic field can be. When a comet plows through a solar storm or a coronal mass ejection, CME, the magnetic field around it suddenly flips direction. The tail can't keep up. The old one is cut loose, drifting away, while a brand new tail instantly grows in the new magnetic direction. In 2007, NASA's Stereo spacecraft captured this exact phenomenon when a CME slammed into Comet Anka. The images showed the ion tail literally being ripped away, a perfect match to magnetohydrodynamic simulations. Now, in 2025, with multiple comets near the ecliptic during solar maximum, scientists expect several chances to witness such dramatic events in real time. Behind the excitement lies a deeper debate. Some researchers believe this sudden surge of comet activity could actually influence the Sun's behavior. Teams at NASA's CCMC, Community Coordinated Modeling Center, suggest that when multiple active comets pass through the solar wind, their plasma tails could subtly disturb the sun's magnetic field, potentially triggering new CMEs or intensifying existing ones. Their simulations show field lines wrapping around the comets, snapping, and reconnecting, just like a stretched rubber band breaking under tension. With up to 5 CMEs per week expected in late 2025, this scenario could produce a chain reaction of tail disconnections, plasma turbulence, and maybe even geomagnetic storms detectable on Earth. But not everyone agrees. Scientists from the Parker Solar Probe and Solar Orbiter missions argue that comets are merely passengers, not drivers, in this story. Their data suggests the sun's own magnetic cycles dominate these events, with comets acting as tracers, markers of turbulence rather than causes of it. One thing both sides agree on: 2025 will be an unprecedented natural experiment. For months, spacecraft, ground-based telescopes, and even amateur astronomers will all be watching the same celestial laboratory unfold in real time. Among all 7, 3I/Atlas stands apart. This isn't just another icy visitor, it's an interstellar object, only the third ever confirmed after Oumuamua in 2017 and Borisov in 2019. Its orbit is hyperbolic, meaning it's not bound to our sun at all. It entered our solar system from deep space, and when it leaves, it's gone forever. Early readings from the Hubble Space Telescope and James Webb suggest its core could be anywhere between 320 meters and 5 kilometers wide. But what's truly jaw-dropping is its coma, the halo of gas surrounding it, spanning nearly 700,000 kilometers, almost the size of Jupiter. And it's expanding every week. Even stranger, its chemistry doesn't match typical solar system comets. It's loaded with carbon dioxide and other exotic gases, while water vapor and cyanide, the usual suspects, are almost absent. That chemical fingerprint hints that it formed in a completely different planetary nursery, under different conditions. As 3I/Atlas swings around the sun, it'll leave behind a faint trail of dust that Earth may cross in 2026. That could let scientists sample interstellar material for the first time in human history, no spaceship required. From late October to early November 2025, the night sky becomes a stage. For most skywatchers, the show begins before dawn on October 21st, when Comet Swan makes its close pass to Earth. Under dark skies, its tail could stretch up to 2.5 degrees, 5 times wider than the full moon. Binoculars or small telescopes will reveal the structure of its glowing tail. A week later, as Swan fades, Comet Lemon rises in the evening sky, low in the southwest just after sunset. It could be the brightest of them all, visible to the naked eye from rural areas. Between November 6th and 12th, it'll be at its most dazzling. Even when some comets slip behind the sun, you won't miss the action. NASA's SOHO and Stereo spacecraft stream live images online, showing these icy bodies as they pass through the sun's outer atmosphere, tiny moving sparks against a storm of plasma. Anyone can tune in and watch real solar system drama unfold. Forecasting comets is an art full of surprises. A comet expected to blaze at magnitude 3 can fade to 6, or suddenly erupt brighter than Venus overnight. Tiny differences in dust grain size, ice composition, or sunlight penetration can rewrite predictions completely. Even advanced thermophysical models can't account for hidden fractures or pockets of volatile gas waiting to burst open. For 3I/Atlas, the mystery is even deeper. We don't know its exact size, density, or full chemical mix. Every new image reshapes what we think we know about how comets behave, and how interstellar chemistry might differ from our own solar recipe. So, what will the comet swarm of 2025 ultimately bring? Maybe dazzling tales across the night sky. Maybe new insights into solar magnetism, or even interstellar chemistry. Or maybe, just a reminder that our solar system is far from static. It breathes, it changes, and sometimes, it surprises us all at once. For astronomers, this is the season of the century. For everyone else, it's a rare invitation: step outside, look up, and witness the solar system alive in motion. Because who knows, your next glance at the sky might catch a comet that hasn't visited since before humanity even existed.